Imagine a tiny, tenacious traveler. It's smaller than a school bus, powered by less energy than it takes to run a light bulb, yet for nearly half a century, it has journeyed farther than any object made by human hands. This is the story of Voyager 1, a story of exploration, of discovery, and of a silent message sent out into the vast, cosmic dark. It left our world long ago, a whisper of humanity sent sailing on the solar winds. Its mission was to visit the giants of our solar system, Jupiter, Saturn, and then to keep going, forever. It carries with it a golden phonograph record, a time capsule of our world, just in case someone, or something, is out there to find it. This little machine is our silent ambassador to the stars. The story of Voyager 1 begins with a cosmic alignment, a celestial dance, that happens only once every 176 years. In the late 1970s, the outer planets of our solar system, Jupiter, Saturn, Uranus, Neptune, were lining up in a perfect cosmic conga line. This rare event made a grand tour possible. A single spacecraft could use the gravity of each giant planet to slingshot itself to the next one, like a stone skipping across a cosmic pond. So, on September 5, 1977, just after its twin, Voyager 2, had launched, Voyager 1 lifted off from Cape Canaveral, Florida, riding a pillar of fire toward the heavens. Its primary mission was to explore Jupiter and Saturn in unprecedented detail. Before Voyager, our images of these worlds were fuzzy blobs from Earth-based telescopes. We knew they were big. We knew they had moons, and, in Saturn's case, spectacular rings. On Valentine's Day, 1990, long after its triumphant encounters with Jupiter-Saturn Voyager, one performed one last iconic act before its cameras were powered down to save energy. At the urging of the great astronomer Carl Sagan, NASA commanded the spacecraft to turn around and take one final look back at the solar system it was leaving behind. From a distance of nearly 4 billion miles, it captured a series of images, a family portrait of our planetary neighborhood. In this mosaic of distant worlds, one image stands out not for what it shows, but for what it implies. It is the image known as the pale blue dot. In this famous photograph, Earth is a tiny speck, a single pixel of faint blue light, suspended in a sunbeam almost lost in the vastness of space. It doesn't look like a world teeming with life, with cities, oceans, dreams. It looks insignificant, a lonely mote of dust. Carl Sagan described it best. Look again at that dot. When Voyager 1 arrived at Jupiter in March 1979, our understanding of the King of Planets was changed forever. We expected to see the Great Red Spot, a storm known for centuries, but we did not expect the sheer chaotic violence of Jupiter's atmosphere. Voyager's cameras revealed a swirling, turbulent world, cyclones, anticyclones with storms larger than our entire planet. The clouds were not just placid bands of color. They were dynamic, flowing rivers of ammonia and water ice, moving at hundreds of miles per hour. It was a masterpiece of fluid dynamics, painted on a canvas 1,000 times the size of Earth. But the real surprises were found not on Jupiter itself, but around it. Voyager 1 discovered that Jupiter, like Saturn, has a faint, dusty ring system. This was completely unexpected. Scientists had thought rings were a unique feature of Saturn, but here was a delicate dark ring, likely made of dust kicked up from Jupiter's inner moons by micrometeoroid impacts. More shocking still was the discovery on the moon Io. Instead of a dead, cratered world like our own moon, Voyager 1 saw a hellish landscape racked by constant volcanic eruptions. Sulfurous volcanoes lofted material into space, creating a massive plasma torus that interacts with Jupiter's powerful magnetic field. A tiny moon shaping a giant's environment. A year and a half after its rendezvous with Jupiter, Voyager 1 set its sights on the jewel of the solar system, Saturn. From Earth, they looked like smooth, continuous bands of light. But when Voyager 1 arrived in November 1980, it revealed a level of complexity that was simply breathtaking. The rings were not a few solid bands, but a dizzying, intricate system of thousands upon thousands of individual ringlets, like the grooves on a phonograph record. They were made almost entirely of water ice, with particles ranging in size from dust grains to houses. The mysteries began to pile up immediately. Voyager 1 discovered strange, dark, radial features in the B-ring that looked like spokes on a bicycle wheel. These spokes would form and dissipate over a matter of hours, seemingly defying the laws of orbital mechanics. For a long time, their cause was a complete puzzle. The best theory today is that they are phantom-like clouds of fine, electrically charged dust, levitated above the main ring plane by Saturn's magnetic field. Even more bizarre was the behavior of the F-ring, a narrow, wispy ring just outside the main system. Voyager 1's images showed it was kinked, braided, and clumpy, as if it were being constantly stirred and twisted by an unseen hand. The culprits were soon found. Two tiny moons, Prometheus and Pandora, orbiting on either side of the F-ring. These shepherd moons use their gravity to confine the ring particles, keeping the ring from spreading out. Their gravitational tugs and pulls are what create the braids and knots, a beautiful and chaotic dance of gravity. Voyager 1 also gave us our first close-up look at Saturn's giant moon, Titan. Its thick, hazy orange atmosphere was composed mostly of nitrogen, much like Earth's. Hints of a methane cycle made it irresistible for future exploration. After leaving Saturn behind, Voyager 1 began its long, lonely journey toward the stars. For decades, it traveled through the outer reaches of the solar system, a region dominated by the solar wind. This bubble of solar influence is called the heliosphere. Scientists knew that eventually Voyager 1 would have to cross the boundary where this solar wind crashes into the thin gas of interstellar space. This boundary is called the termination shock, and nobody knew exactly what it would be like. In December 2004, after 27 years of travel, the speed of solar wind particles suddenly dropped. Plasma temperature and density shot up. The magnetic field intensified. Voyager 1 had crossed the termination shock. It had passed through a literal wall of fire at the edge of our solar system, entering the Helios sheath, a turbulent sea where the solar wind is compressed and heated. The shock was much farther out than most models had predicted, showing our solar bubble was larger and more robust. Yet the magnetic field didn't behave as expected. It was a sign that our models were too simple. For years, Voyager navigated this choppy frontier, sending back turbulent, fluctuating data. Here, our sun's breath meets the galaxy. After crossing the termination shock, Voyager 1 spent years in the Helios sheath. Then, in the summer of 2012, everything changed again. A sharp drop in solar particles and a massive spike in galactic cosmic rays signaled that on August 25, 2012, Voyager 1 had crossed the heliopause. It had left the sun's magnetic bubble and entered interstellar space. For the first time, an object from Earth touched the stuff between the stars. The final confirmation came from what it heard. Its plasma wave system detected faint, persistent vibrations in 2012 and 2013. Solar outbursts sent shockwaves that rang the interstellar plasma like a bell. By measuring the vibration frequency, scientists calculated plasma density about 40 times higher than inside the heliosphere. When converted to audio, it becomes a low, steady hum, the ambient noise of the cosmos. As Voyager travels farther, the hum's pitch slowly rises, revealing a denser interstellar medium. Not flashy headlines, but deeply significant measurements of our galactic environment. Voyager 1 is our scout, reporting back on the open sea. A faint whisper carried across the light years. For a machine designed in the 1970s, flying through harsh radiation, Voyager 1 has been remarkably reliable. But it is not immortal. In May 2022, the team noticed something deeply strange. The attitude control system began sending back gibberish, garbled, nonsensical data, yet the signal remained strong and steady, and the antenna stayed locked on Earth. It was as if a ghost had taken up residence in the machine. Engineers suspected the system was routing telemetry through a dead or corrupted memory section. After careful analysis, they commanded a switch to known good memory, a risky move that worked. The data returned to normal, turning a near catastrophe into a testament to robust design. What caused it? A cosmic ray? The slow decay of an ancient computer? We may never know. Voyager 1's mission is now pure exploration into the unknown. Its radioisotope generator is slowly fading. Instruments are being shut down to conserve power. Soon the transmitter will fall silent, but the journey will not end. It will sail the galaxy for eons. A silent ghost ship carrying memories of a world it left behind, a message in a bottle. Voyager embodies our curiosity, our intelligence, and our hope. More than a machine, it is an idea that even a small species on a tiny planet can reach for the stars and become part of the cosmos forever.